I'm Ned Bellavance, and today I'm going to talk a little bit about testing Vault ACL policies with Python, and just about testing Vault policies more broadly. That's kind of apropos because the previous presentation was all about testing with Terraform, with the new testing Terraform framework. Unfortunately, within Vault, there's no built-in testing framework yet. Maybe that'll come in a future iteration. Before we dive into the topic deeply, I have a bit of a confession. I'm bad at writing ACL policies for Vault. Like, I'm bad at it. I think I have the path right. I think I got the capabilities right. And then I try to do the thing, and I can't. Or I realize I gave way too much permissions to somebody. I'm just not good at it. And that's OK. And I suspect some of you are not fantastic at writing them either, and that's no fault of your own. It turns out that writing policies is difficult. So we're going to do a little pop quiz together. We're going to look at a series of Vault policies, and we're going to try to figure out what the effective permissions are on a given path. You can feel free to call out the answers if you think you know them. Let's look at the first one. So this is a very simple policy. The path is secret team A dev slash. That slash is important, as you probably already know. And the capabilities we're granting here are read and list. So what can a policy holder, someone who's been assigned this policy, do at the path secret team A dev app1? Any guesses? Nothing. You get denied. You can't do anything because app1's not included in the path. Let's try a slightly different one. All right, so secret team A slash dev. This one's a little trickier. Any guesses on that one? Nothing. You can't do anything there. And you might go, whoa, that's weird. That's not what I expected. But Vault is very literal about paths. And this has come to bite me more than once. I'm sure it may have bitten you as well. All right, so this one's kind of a gimme. Again, all right, secret team A dev app2 API key. We are denied. You get nothing here. Even though the path is longer, that doesn't help you out at all. So let's test the actual literal path that is in the policy. Any guesses on this one? Read and list. Yeah, OK, so we finally are able to do something at that exact path. And what's funny was when I was writing these examples, I had to check because I wasn't sure if I got each one right. So did I use the testing framework you'll be seeing? I did. How about that? All right, so let's make things more complicated. We're going to do a wildcard policy here. We're going to have a placeholder in here. So secret slash plus slash dev slash star. Read, list, and create are the capabilities. So what can the policy holder do at secret team A dev app1? Yeah, you can do all the things. Create, list, read, because that star says anything that goes beyond this path, you'll get these capabilities on it. So let's try a slightly different one. Ooh, this one's team B now. Uh-oh. What if they can access team B stuff? Can they access team B dev app2? Yes, they can. Create, list, read. If you did not mean to give someone permissions to team B, they're only supposed to have team A, you just screwed up. Oops. All right, one more here. What about secret team B slash dev? Denied. Nope, it's before the slash star, so that may trip you up as well. So that's wildcard policies and simple policies, but hey, we've got a little bit more than that because there's a special kind of path that requires a special kind of permissions, and that they're called root protected paths. sys/audit is just such a root protected path. So if I have this policy with the capabilities read, create, and update, you could probably figure out sys/audit deny. You have no permissions, right? It's before the slash star. But what about this? Sys/audit file1. What permissions would you expect to have there? You'd think you'd have read, create, and update, right? It matches. Nope, you're denied. Why are you denied? Because you need pseudo capabilities to perform operations on a root protected path. Oh boy, so that's going to come back later. Keep that in mind. So based off these examples and whether or not you got all of them right, maybe you did, maybe you didn't, I hope I've convinced you at the very least you need to test the intent of your policy. Does this policy actually do what I think it does? And does it do more than I want it to? So two kind of different test cases that you have to take into account there. But there's more. But wait, there's more. You might also want to test for compliance. I have certain standards. Well, I mean, maybe I have standards. Who's to say? But your organization probably has standards. And those standards might say, if a policy grants access to a root-protected path, maybe you need someone to approve that before you put that into production. You might want that. So you may want to test for compliance. And then lastly, you may want to test during assignment, should this person really have access to this policy? Should your level 1 help desk have access to the Vault admin policy? Yeah, probably not. Oops, did you accidentally assign it to them? OK, we want to catch that before it actually happens. So we've got 3 different kinds of tests that we're trying to do here. How would we go about testing for each of these? So this was what was mulling in my brain about a year ago, and I started thinking about the various options for it. So let's think about testing for intent. I came up with 2 basic options. Or if I'm being honest, I came up with one option, realized it wasn't feasible, and then came up with the other option. So the first option I came up with was actually test the policy. Create the policy, test it against an actual path, find out what the results are from Vault. Seems like a good idea. The other option that I actually ended up on was using the Vault API in a very convenient endpoint that exists. We'll get to that in a moment. But why didn't actually test policy work? Well, first of all, you need a real live Vault system. Not a problem. I can spin up a dev Vault server. That's super easy, right? But you also need a real live path to test against. And if you're testing a key value store, that key value store engine has to be actually mounted, and the actual path needs to exist to test against. That's not too hard, but say I'm testing an LDAP secrets engine with a particular role. Well, now I need to mount the LDAP engine. I need to configure it appropriately, and I need to have that role actually exist before I can do any of this testing. That's a lot. And am I going to do this against my prod server? Do I feel comfortable deploying even test policies against my prod server? No. OK, so this is complicated. I don't want to do any of this. Instead, I discovered the capabilities endpoint. This is a very cool endpoint. And what it does in the Vault API is it just calculates what the effective permissions are at a given path from a given token. So you give it a token, you give it a path, and it says, here's the effective permissions that you have at that path. Very useful. It doesn't actually check the action. It's not actually running against that path, so that path doesn't have to actually exist. It's just doing a calculation. What it doesn't calculate is whether or not you need pseudo. So we're going to have to account for that later in our testing process. What did I end up using to do this testing? Well, you may have gleaned this from the name of the presentation. I ended up using Python. Why did I pick Python? Honestly, I don't know Python that well, so that was kind of a weird choice on my part. I wanted to force myself to learn Python better. And also, there's a Vault library called HVAC, which has nothing to do with air conditioning, that will do all the Vault client creation and tokenization and all that kind of stuff for you. What about testing for compliance? What are the options there? Well, you could write your own custom policy engine. That sounds awful. Don't do that. Friends don't let friends write custom policy engines. You can use Sentinel. If you have Enterprise, Vault, or Terraform, you could use Sentinel for that. Not everybody's going to have that. I don't always have access to that. So the other option is to use Open Policy Agent. And I think you can guess which one I went with, which was Open Policy Agent. The thing about OPA is, if you've used it before, you know that the data input that it's expecting is JSON. And Vault policies are not written in JSON. So what you need to do is take your pretty HCL Vault policy and convert it into JSON. And once you do that, now you can feed that into OPA and run some Rego rules against it, get a result, make a determination. So I wanted to include that capability in the script that I was writing. Testing for assignment, kind of the same options as testing for compliance. Write your own custom policy engine, don't do that. Use Sentinel, maybe. Use Open Policy Agent, absolutely. Especially if you're using Terraform to manage your Vault policy deployment. When Terraform plan runs, you can send that plan to JSON and have OPA evaluate it, and everybody's happy. So let's dig into the actual testing workflow for the intent one, because that's the one I wrote in Python, and that's the name of the talk. So I should probably talk about that. So this is the testing structure I came up with. And I'm kind of borrowing from existing testing workflows that are out there. All the policies are sitting in a directory called policies, because I'm basic, and that was easy. But I have a subdirectory called tests. All the tests live in that subdirectory, and the name of each test maps to the name of the policy. So we have our admin policy.hcl, and we have our admin policy.yaml. Yes, it's written in YAML. Everybody take a deep breath. It's going to be OK. I like JSON better also, and I like HCL even better, but it is what it is. So what's actually in these two files? If we look at the tacoteam.hcl policy, there's a standard Vault policy. And then in the tacoteam.yaml, I have a series of tests I've defined to test the capabilities as defined within my policy. And there's 3 entries for each test. So it's a list of tests. The 3 entries are path, actions, and result. So the path is the path you want to test. It doesn't take wildcards. It's a literal path. This is the path I want to test. Actions is a list of actions that you would like to test against that path. And then result depends on whether you want to test that you are allowed to do these things or that you're not allowed to do these things, because you have to account for both scenarios. True says the actions I've included here are allowed at that path. False says the actions I've defined here are not allowed. So if I didn't want to grant access, I can test to see if I accidentally did. So those are the 3 fields that go into the test. Let's look at a demo of how it actually runs. And I'm going to try to keep up with my pre-recorded video, so we'll see how that goes. All right, so I have an existing policy here called taco.hcl. I'm going to add an additional entry into it, and then I'm going to write a test for this new entry. The new entry is secret/data/plus/taco/star. Yes, I added in the star and the plus sign because that's the stuff that messes me up. And for capabilities, I'm going to grant the capabilities of create, list, update, delete, and read. If I'm remembering correctly, I am. Good for me. And now I'm going to write 2 tests to test the intent for this policy. The first one is going to look at a path, and I'm going to test to see if I'm able to perform operations on this path. So the path is secret, data, truck, taco, recipe. And for the actions, I'll set up kind of the same actions that I granted through the capabilities. So create, read, update, and delete, I think are the 3 that I put in there. Memory serves pretty well. All right. So I'm going to test those actions, and this is an affirmative test. I want to make sure I'm able to do these things, so I'll set the result to true here. For the next one, I want to make sure I didn't accidentally grant access to a path I didn't intend to. So I'm going to put a different path here of secret, data, truck, API keys. Maybe I don't want the taco team to have access to the API keys. So I'll put the same actions in here that I don't want them to be able to do. And then for the result, instead of true, I'll set that to false, implying that I don't want this policyholder to have any of these permissions. So now I've written my tests. The next step is to actually run the script. So let's take a look at what that encompasses, if it will do a thing. There we go. OK. So the way that the script is invoked, the script is called testcapabilities.py. You invoke it with Python, and it takes a few arguments, more than what's shown here. But the arguments that I'm showing here, -d says, this is the directory where the policies exist. It assumes there's a subdirectory called tests. And so it looks for matching policies in all of those. -v says, hey, spin up a temporary Vault server for me. So just spin up a dev Vault server, and then kill it when the testing's done. And -j says, I also want you to convert all my policies to JSON so I can feed that into OPA later. So let's see this actual thing run. It's going to run soon. Yeah, all right. So the output is in JSON, probably not very useful looking at the command line. So I'm going to dump this out to a results.json file. Let's open up that file, and then I'm going to use the wonderful prettify JSON in VS Code to make it actually readable. And let's go down to the 2 tests that I added. So remember, the second one was to make sure I didn't have access. The actual actions is deny, and the input actions are all the other ones, but the desired result is false, so this test passes. I don't have access to this. The second one was an affirmative test. I want to make sure I do have create, update, read, and delete at this path. And the actual actions include all of those input actions. So this test also passes. That's awesome. So I wrote a couple tests. I feel pretty confident about this policy, and maybe I'm about ready to roll it out to my Vault server. And that's the sort of thing you'd probably want to add some automation for. I had the -j in that command, and that converted my two policies to JSON as well. So there's two new files that you see here. One is pseudo policy.hcl.json. If I make it look pretty, there's the JSON version of the HCL policy. And same thing with the other one. Now here's the JSON version of my taco policy. Now I mentioned earlier that the capabilities endpoint doesn't do so well with pseudo. It has no idea, does not compute that. So when it calculates your effective permissions on a root protected endpoint, it does not take pseudo into account. So I have to take that into account in the script and test when actions should be allowed. So what I did is I went into the Vault documentation, and unfortunately there's no easy way to pull this information, so I had to type all this by hand. Now you don't though, because you can grab this from the repository. One thing I noticed about all the root protected paths is that they all start with the prefix sys, pki, or auth. So in order to do a very quick check, during the script, I just check to see if the path being tested starts with one of those prefixes. If it doesn't, I can move on with my life. If it does, then I need to check to see if it's in the list of root protected paths. And so I have a list of root protected paths in here that has the path with some additional regex on the end, as well as the actions that are protected at that endpoint. And so I wrote a function in Python that basically takes that path and the actions and calculates whether or not pseudo is required. If it is, it returns true. If it's not, it returns false. And I take that into account when I'm testing the policies. So if I had a policy like this that's referencing two root protected paths, one of them has pseudo included. So sys replication reindex has pseudo included. So the create update should pass. The sys rotate is also protected, but I didn't include pseudo in there. So when I run the test, that should come back as failed, because even though I have create an update, and that's what the capabilities endpoint is going to hand back, I don't have pseudo, so it's not going to work. So that's how I got around the pseudo issue. Let's dig into the automation side of things. What I showed earlier was running the script locally, which is great for local development. I'm just trying out some new policies. I want quick and dirty. But chances are you're probably going to want to integrate your testing into an automated pipeline of some sort. So I'm going to assume that you're using version control for your policies, which you probably should be doing, and that you have some sort of CI/CD process set up for automating the deployment of your Vault policies. So it would start with code check-in. I check in my code probably as a feature branch to GitHub or Bitbucket or whatever you're using for your VCS. You're probably going to want to check the syntax of your policies and make sure that at the bare minimum it's valid HCL. And then once you've passed that very low bar, you would create a pull request targeting the main branch. And that would kick off a series of tests before it gets merged. And so at a bare minimum, you probably want to do the intent testing that I was showing. You may also want to do compliance testing by invoking OPA, because that may trigger additional necessary approvals for this new policy. And if you're doing your assignment of policies through the same workflow, you might want to include the assignment testing as well. Somebody else is, well, hopefully, somebody else is reviewing your pull request and you're not doing self-review. They're going to look at the results of the test and determine, yeah, this looks good, or no, you have to go fix a few things. But once everything looks good, they'll merge the code, which would kick off an automation process, probably Terraform, if we're being honest. And that will actually apply these updated policies to the target Vault deployment. Maybe this is a multi-stage thing. I'll leave that up to you. But that's just the overall idea of the testing pipeline. So I put this into practice using GitHub Actions to see how it would all work out. So what I did is I wrote a composite action in GitHub Actions that can be invoked by another action. What this composite action does is it takes two inputs, a Vault address, so how can I talk to the Vault server? It has a default of the loopback on port 8200, so it assumes you might be using a dev instance. But you can use a production or an external instance if you wanted to, and an admin token for the Vault server. Now that token doesn't have to be a root token. It just has to be able to create and delete policies. And it also has to be able to contact the capabilities endpoint and provision a token that has the policy associated with it, because that's basically what the script is doing. The result is going to be the same JSON that we saw earlier that's passed back as output from this composite action. And I folded this composite action into a larger GitHub action that starts by spinning up an instance of Vault using a container. So it just grabs the latest version of the Vault container, spins it up in dev mode, and passes a token that's going to be used as the root token. And since this is an ephemeral instance that's not going to hold any production data, I feel OK hard coding the token. Could you use a variable? Absolutely. I leave that up to you. Once it spins up the Vault container, it will then run, check out the code, and then run the Vault tests by invoking that associated composite action. It's going to pass it the directory where the policies can be found, as well as the Vault token that's going to use. And then in a final step, it's going to print the results out to the pull request as a comment. So let's see this in action. I've already updated my policies. I updated my taco policy, and I wrote my updated tests. So now I'm going to create a feature branch before I commit them. And so that feature branch, I'm going to call it taco_update, because I'm simple, and that's an easy thing to do. So I'll create this branch, and then I'm going to commit these two files to the branch. So this includes my updated policy and the tests that I wrote to test it. Commit that, and then publish the branch up to GitHub. And then we'll jump over to GitHub. GitHub sees that, hey, you have a new branch. Would you like to create a pull request? Yes, yes, I would. So I'll create a new pull request, and this is going to kick off that GitHub action we were just looking at. So that should kick off in a moment. There we go. So now it's going to run the tests that are included in the script. And if I go into the details, you can see the process as it unfolds. So it already spun up the Vault container. It's now running the Vault tests. When it's done the tests, it's going to kill that Vault container that's running our temporary Vault server, and then add the comment back to the pull request. So if we go back to the pull request, it added in the comment. It converted the JSON to a nice table, so you don't have to try to read bare JSON. And it includes the policy name that was tested, the path that it was tested against, and the result of the test, as well as some other information. The thing you're probably most concerned with is that test result column. Did it pass? Did it fail? The second one failed. And why did it fail? Well, I can see that I tested the path secret data taco. The test result was fail. The desired result was false. So this was it shouldn't have access to this. I checked to see if read access was allowed. It was. That means this test failed. Maybe that's what I intended, and I need to amend my policy. Or maybe I wrote the test wrong, which is entirely possible, and I have to amend that. It could go either way. So once you've reviewed the results of the test, if you're happy with what it did, then you can go ahead and merge this pull request into the main. And once that is done, that could, in theory, kick off another GitHub action, which would deploy the actual policies out to your Vault server. And then I'll delete the feature branch because I did it. I got it back to main. So that is the overall workflow from an automation perspective of what I put together. Some final thoughts regarding this. I hope at the very minimum I've convinced you that testing your Vault policies is a really good idea. Like I said, I'm bad at writing Vault policies. I acknowledge that, and I own it. And so what did? I wrote something that can help me write better policies by testing that what it actually does is what I intended it to do. So even if you're not going to use this testing framework, I definitely recommend developing some testing framework. Python and OPA are great for testing. Python's great if you're not really sure exactly what the testing is going to look like, so you need to customize it a bit. OPA's great if you know you got JSON coming out and you're really just trying to test it against a set of rules written in Rego. I will admit that OPA's not the easiest thing to grok, so I definitely recommend, it sounds a little funny, but go to ChatGPT and ask it to write the Rego for you. And that'll get you like 70% of the way there. I'm going to keep using that 70% that was from the keynote because I like that. It'll get you 70% of the way there. Then you can tweak the Rego. But for me, staring at a blank page, I'm like, I forget how to write everything. And lastly, your policies really should be managed with version control and deployed through some sort of automation pipeline. The problem with Vault, when it comes to policies, is it has no history of previous versions of the policy. So when you overwrite a policy, the old policy is just gone into the wind. So you probably want to manage the versioning of your policy in some way. Version control seems like a pretty good way to do that. If you're interested in looking at the example code, you can find that. You can go to the short link bit.ly vault-policy-test, or you can hit the QR code there, or you can just go to my GitHub account. It's Ned1313, and you should see the Vault testing there. Please be gentle. I am not a Python developer by any stretch of the imagination. I am sure my code is terrible. So be kind. If you see room for improvement, I'm more than happy to collaborate with others. I'm Ned Bellavance. That's been my presentation. You can find me on Ned in the Cloud if you're interested. If you have questions or want to talk about this more after the presentation, let me know. I also have Terraform tacos and Vault burritos. So if anybody wants either of those, come up and find me afterwards. I've got a cache of them, and I don't want to bring them back home. That's going to do it for me. Thanks, everybody. Go enjoy lunch and enjoy the rest of the conference.